Hello dear children, this is the 6th lecture on kinematics. So previous links related to the previous lectures will be given in the description, just go through it. In today's class children, we will be discussing the equations of motion for an object which is sliding on the smooth inclined surface. So let us see that children here. So here children, as per the diagram here, as per the topic which we are going to discuss, here AB is a inclined surface which is making an angle theta with the AB. So on this AB inclined surface, children, smooth, when I say smooth children, friction is neglected. Friction might be due to air or friction due to the between the surfaces. All type of frictions are neglected. Is that clear? So that is what we can say it as a smooth surface. So over this AB, a small object, a small particle or a tiny anything kind of thing whose mass m is placed here. Okay, so that its weight will be acting vertically downward direction. Okay children, fine. Now our intention is to derive equations of motion for this body which is sliding on this smooth inclined surface. Children, whether the body is placed on horizontal surface or inclined surface or whatever is the surface children, what will be the direction of acceleration due to gravity? Yes, direction of acceleration due to gravity is vertically downwards only, right? Whatever may be the position of the object, the acceleration due to gravity will act with the vertically downward direction only. So that is how it is shown. Look at here. So this is the direction of acceleration due to gravity. Children, here one very important thing here. So one important condition is that, so with whatever the acceleration the body is sliding, that is less than or equal to the g. Should not exceed g value. Should not exceed g value. It won't also. So if a value is exceeding g value, then it is not a freely falling body. It won't be considered as a body which is like moving under the action of gravity. Because as the a value is increasing more than g means, yes, we are applying the external force. Then only in that case only a exceeds g. Otherwise, a is less than or equal to g. It should not exceed. A cannot be greater than g in this case. Okay. So here 2 points you should remember. Frictions are neglected. Second point, a should not be greater than the g value. It is equal or less than. Actually, it is less than only. Equal is not possible. It is. A is less than g only. Clear? Fine children. Now children, so as now it's very clear that g value will be acting vertically downward direction only. That is fine only. And if you can see here, this inclined surface is making angle theta with this AC. Okay. And the body is going along the surface. Its motion is along the inclined surface, right? So now we should know the acceleration, with what acceleration the body is sliding along the AB. So for that, we know that here acceleration, see, it might be due to gravity or what it may be, it's acceleration only. And the acceleration is a vector quantity and it can be resolved into two rectangular components. Okay, fine children. Now children, as this angle is theta, this is how much? Yes, it is a 90 degrees, right? Obviously, it is a 90 degrees. Okay. It is 90 degrees. Then what will be this angle? This will be 90 minus theta. Because the sum should be 180, right? 190 minus theta. And here you make it a one out. Sir, this is what actually, see, this is neglected. This gap is neglected. That's what actually we say that it is a what we can say very tiny particle. It is not a huge mass actually, very tiny particle. So that this gap is neglected. So that this entire one will take as 90 minus theta only. Okay, fine. Now let us resolve g into two rectangular components. Okay, now. So one is along the surface because it has acceleration, right? Because it is going along the AB means what, it should have some acceleration. And for this the vertical component is like this, you will get. This is a vertical component. But thing is that which one is a horizontal component and which one is a vertical component. Okay, children, don't think that just this is a vertical, this is a horizontal. No, it is not. It depends on the angle. With what axis it is making angle theta. Along with that, we can take a cos component, and other than that, it will be a sine component. So, children, as it is theta, it is a 90, it is 90 minus theta. And this total should be how much, children? This total should be 90 only, right? Yes. To have this total 90, and this should be how much, children? This should be theta. Try to understand. this should be theta. So then only the sum total will be 90 minus theta plus theta will be 90, because this is a normal, children, this is a perpendicular line drawn to AB. So angle must be 90 only. Now, as this resultant one is making angle theta with this axis, yes, so G cos theta will be along this line only. And obviously, as it is a G cos theta, this is going to be what? G sin theta. Children, don't get confused. Previously we discussed, look at here. It is a x axis, it is a y axis. It is a resultant vector, let us say A. Make an angle theta. So then this will be the A cos theta component and this will be the A sin theta component. So you have to see the angle. You have to see the angle. It is not like a vertical or horizontal. No, we have to see the only angle. So the angle with which it is the axis with which it is resultant over making angle theta, that will be the cos component, and other than that it will be sin component. So that's what here this resultant G is making angle theta with this axis, so that this we are taking it as a cos theta component and this one will be a sin theta component. Is it clear, children? Okay, na? Fine. Now, so we got to know with what acceleration the body is going. Yes, so this is the acceleration with which it is sliding. Okay, children, try to understand. Very important. Children, this is not a vertical motion, right? See, in the case of vertical motion, whether it is an upward journey or a downward journey, G value is negative only, right? Okay, but in this case here, so when you are going, so when a body is sliding in this direction, okay, now we take it as a plus. Okay, for suppose if a body is going, see, it is not always the body slides down only, right? It can slide upward direction also. When it slides upward direction, we can take as a is equal to minus G sin theta. Minus G sin theta. Now let us write here, children. So here we know these equations of motion, right? So these equations of motion we already derived and already discussed. Okay, now let us write for a downward journey, children. So first downwards, let us write for a downward journey. I mean B to A. So then V is equal to U place, in the place of A just you put G sin theta. G sin theta into T, and S is equal to ut plus half G sin theta T square, and V square minus U square is equal to 2 G sin theta into S. Next, Sn is equal to U plus G sin theta by 2 into 2n minus 1. So these are the equations of motion for an object which is sliding on a smooth inclined plane downward direction. Whereas if it is upward, children, look at it. If it is for a upward case, upward means what here? A to B. Then simple, in the place of G sin theta, we will substitute minus G sin theta. Then we get equation of motion. V is equal to U minus G sin theta into T. S is equal to ut minus of G sin theta into T square. Then V square minus U square is equal to minus 2G sin theta into S, and Snth, not Sn, sorry, this is Snth. This is Snth. This is Sn. Okay, Snth is equal to U minus G sin theta by 2 into 2n minus 1. So children, so these are the equations of motion for an object which is sliding on the smooth inclined surface. Just copy this. One or two small numericals, we will do it. Come on. Children, if a body is starting from rest, for example, at a point B, if a body is starting from rest, then obviously U will be 0. So in all the cases, you can put a U value 0, then you will get the resultant, whatever the equation of motion required, which we will obtain, so that you can apply to solve the numericals. Okay, come on. Fine, children. So in a given question, they are asking us to find the time taken to reach point A. Try to understand, children. Time taken to reach a point A, and it is given that as a body is sliding freely, so this is given as a U is equal to 0. Let here velocity will be V. Okay, Children, here let us take this BC is a height, H you can take, okay, and AB, the length of the inclined surface, is given as L. Now what we need to do? We need to calculate the time taken to reach point A. So children, what is the acceleration which we got here? Yes, we got A is equal to G sine theta. Okay. From this triangle, children, can you write like this? Sine theta is equal to opposite side by hypotenuse, that is BC by AC. So from this we can write sine theta is equal to H by L, or you can write L is equal to H by sine theta. H by sine, depends on the question asked, you can use these two relations. Okay, fine. Now let us take the distance traveled in t seconds, that is S is equal to, we know that ut plus half at square. Now this is going to be 0 anyhow. So here S is what, children, here? Yes, S is nothing but what actually? Distance traveled, right? S is nothing but L here. Try to understand. S is equal to AB is equal to, that is L. So here L is equal to half into A value, how much we got, children? Yes, it is a G sine theta into t square. So t square you make as a subject. So get this to this side, it will be 2L by G sine theta. Now here L is equal to, you substitute this entire value. So this is going to be 2G sine theta into H by sine theta. So sine theta into sine theta square. This will be 2H by G sine square theta. As a t square is equal to this much, children. So t is equal to square root. So this will become, sine theta will come outside, right? 1 by sine theta into square root of 2H by G. So this is a time taken to reach point B to point A, where here u is equal to 0. Children, here you may get a one doubt, sir, why you substituted L is equal to this one? Yes, even if you want in terms of H and L, so here only you can write sine theta is equal to H by L. So we also can write like this equation, children. So from here only everything will change. What conclusion we want actually. So for suppose, children, in the place of sine theta, let us substitute H by L. Then what you will get here? L is equal to half into G into sine theta plus H by L into, it is a t square. Get this L square this side, it will be L square is equal to GH by 2 into t square. So here t square is equal to 2L square by, it is GH. So t is equal to, L will come outside. So this will be 2 by GH. So here if you know L value, H value, you can use this to calculate time. If you don't know the L value, that's what I'm telling. If L value is not given, only angle is given, this height is given H, then you have to use this expression to calculate the time taken. Okay, just copy it. So in this numerical, it is asked that it is just said that a small block slides down in a smooth inclined plane starting from rest. Yes, u is equal to 0. At a time t is equal to 0. Fine. So let Sn be the distance travelled by the block in the time interval n minus 1 to n. That is the distance travelled by the that particle in nth time is given. Now they are asking us to find the ratio of Sn by Sn plus 1. This they are asking us to calculate. Okay. Children, let us write here. We know that here distance travelled in nth second, we know that it is a u plus, it is a by 2 into 2n minus 1. This is general one. But in this case, a is equal, children, we know that it is a g sine theta. First, let us substitute here. So distance travelled in nth, so it's not nth, is equal to u plus g sine theta by 2 into 2n minus 1. Anyhow, as u value is 0, children, so this is g sine theta. You take a 2 inside, it's not a problem, or you can keep outside also 2. This will be 2n minus 1, equation 1. So this is Sn is equal to. Now children, Sn plus 1 is equal to u plus g by, anyhow children directly we can write it because u is 0 only, no need to write u, right? Okay, so this will be g sin theta by 2 into n plus 1, try to understand, n plus 1 minus 1. So let us simplify this. It is g sin theta by 2 into, so with the 2n plus 2 minus 1. Now this is going to be Sn plus 1 is equal to g sin theta by 2. Children, this is 2n plus 2 minus 1 will be plus 1. This is equation 2. Now they are asking us to find the ratio, right? So Sn you can write here, that is g sin theta by 2 into 2n minus 1 by, so Sn plus 1, that is g sin theta by 2 into 2n plus 1. So this total will get cancelled. So Sn by Sn plus 1 is equal to 2n minus 1 by 2n plus 1. That's it, children. So this is how actually you can apply the concept to get whatever actually they are asking us to do it. Okay, children. Thank you so much. All the very best.